Hi, back again. Sorry, battery died. So, ooh, it fell off. The perpendicular bisector is a line perpendicular to a segment at its midpoint. So you have a segment, JK. This is a line, we'll call it line L. This is the midpoint of JK. So a perpendicular bisector is perpendicular and it's going to bisect the segment. Okay, so that's what a perpendicular bisector is. Okay. We're going to draw some altitudes of a right triangle. So if you were drawing an altitude from vertex B to point A, so that's what's going to happen with two of your altitudes. It's going to be just the legs of your right triangle. So that's kind of a unique case. And then also with an obtuse angle. When you draw an obtuse angle, remember those extra lines that we had to draw? The altitude is going to come out like that. Same thing here. The altitude will come down like that. That's a little not very good of a drawing, but okay. So you are to put all these definitions in your book. Median, altitude, draw some pictures just like I did. Perpendicular bisector. We have 4 more theorems that you have to add to your book. Caitlin, you're so close.
Sorry.
Okay. Theorem 3.5 and 3.6. Theorem 3.5 says, if a point lies on a perpendicular bisector of a segment, so here's a point, this is the perpendicular bisector of the segment, then the point is equidistant from its end points at that of the segment. So that means that this is going to be equidistant from this, because this is the perpendicular bisector of the segment, and what's going to basically end up happening is that AB and AC will be congruent because they're going to be the same distance. If that's the perpendicular bisector of this segment, these are going to be congruent. Theorem 3.6 is the opposite of that. If a point is equidistant from the endpoints of a segment, then the point lies on the perpendicular bisector of the segment. So if this point is equidistant from these 2 points, then that's going to be, this segment right here is going to be the perpendicular bisector. So that's theorem 3.5 and 3.6. Then we have 3.7 and 3.8. If a point lies on the bisector of an angle, then the point is equidistant from the sides of the angle.
You said
Equidistant. Okay, so this point is on the bisector of a segment. It's going to be equidistant from the sides of the angle. So here's your point. This is a bisector. Remember, bisectors have equal angle. That's bisecting that angle, and it's going to be equidistant. So those are going to be equal. If a point is equidistant from the sides of an angle, then the point lies on the bisector of the angle. So if we find this point and these two are equal, then we're going to know that that's a bisector of that segment. Okay? So you need to write 3.5, 3.6, 3.7, 3.8. You also need to write the definition, perpendicular bisector, altitude, median. I hope you have fun. Maybe we'll see you tomorrow. Maybe we won't. The key word is ruler falling off my head, or also known as AKA ruler. Okay, bye.